All right, so in the second day of prep for geometry, we're going to be looking at a few different types of words and formulas. So segment bisectors, midpoints, midpoint formula, and distance formula. We're going to start off by defining a few of those words, and then we're going to practice what they mean. So the segment addition postulate says that if A, B, and C are collinear, so they're on the same line, and B is between A and C, then the length of segment AB plus the length of segment BC is equal to the length of segment AC, so the whole thing. Segment addition postulate is basically just part plus part equals whole. So if I knew that this part was, let's say, 8 units long, and if I knew that from B to C was, let's say, 3 units long, then I could use these two pieces and add them up to figure out that the length of the whole thing, or the length of segment AC, the entire length, when you add it up, would be 8 plus 3, which would give you 11. The segment addition postulate also works in reverse. So if you knew that this piece was 8 and if you knew that this piece was 11, you could work backwards using subtraction to figure out that that piece is 3. And so that's something that you'll also need to do. A midpoint is defined as being a point that divides a segment into 2 congruent segments. So if I had a segment here that was, let's say it was labeled A for one endpoint and B for the other, and if my point right here in the middle was, say, M, if the segment contained these markings right here, it would tell me that this piece was the same length as this piece. So from A to M would be the same thing as from M to B. I could also say that those two segments were congruent. So let's see. Let's say if I knew that this one was 4 and if I knew that this one was 4, then I could say that I knew that the whole thing was 8, but also that these two pieces were the same thing. So AM is congruent to MB. Segment AM is congruent to segment MB. And so I could write it out like that. A segment bisector is defined as being a line, a ray, or another figure that passes through the midpoint of a segment. So a segment bisector is basically just something that cuts something else in half. We're not going to worry about drawing a picture for that one right now. We'll see it down here when we practice drawing some examples. So the first question says to sketch, label, and mark the following figures. So we're going to draw pictures of each of these things and what they represent, and then also go ahead and put markings on the picture. The first one says line AT bisects segment UP. So if I have a line that goes from here to here, and if it cuts something else in half, then I can see what that means in the picture. So here's line AT cutting something else in half. Segment UP is the one that's getting cut in half. So if this is my segment right here, UP, this is the one that's going to get cut in half. So if this one's doing the cutting, then this is going to come down here. It'll come down sort of towards the middle. Here's line AT. And then if it's bisecting UP, bisects means that it gets cut in half. So it means that this piece is the piece that's getting cut in half. Whatever the first one is saying that it cuts the second one in half. So this is doing the cutting and this is the one that's being cut. In the second example, it says M is the midpoint of WE. So here's my segment, WE, and M is the midpoint. So I'm not just going to draw M in the middle. I'll put it in the middle, but then I'll also put these markings on the picture so that the markings show that the picture is cut in half. The last one says line M is a bisector of segment OR. So if I draw my segment that goes from O to R, this one says that line M bisects it. So it doesn't have to necessarily come down perfectly perpendicular, but I can draw it that way if I want to. And then when you name a line M, you're just going to draw a small lowercase m. It's not a point. It's just a location right there. And it's usually next to the arrow on the line. There's lots of different ways that you could draw these three figures. This is just one way that you can draw each one, but it is important that when you read the words in each of the directions, you make sure that the picture matches what it needs to. In example number 2, we're going to use the segment addition postulate to find the indicated lengths. So the segment addition postulate says that the part plus the part equals the whole thing. Remember, when you see these two letters K and M next to each other, that's asking you how long segment KM is. So this stands for the length of segment KM. So it's asking you how long it is. KM is the whole thing. And so if I know from K to L is 24, and if I know from L to M is 12, then I can add those two together to get 36. On your papers right here, under where you write 36, I want you to write the word add just so that you can remember how you found that answer. So for the next one, they want me to figure out how long it is from N to Q. So if I know from N to P is 4 and from P to Q is 17, then I can add those ones up as well. And so I can get that the length of segment NQ is 21. And then these two are sort of the opposite of those. So if I know from A to B is 25, and if I know that from A to C is 54, I can work backwards and I can subtract to figure out that from B to C would be 29. And there's two ways to get the answer to that question. You can either do 54 take away 25, or you can think in your head and say, what number would I have to add to 25 to get to 54? Either way, you'll get the right answer. And then the same thing's true on this one too. On letter D, the whole thing is 32. From N to P is 26, and so I would subtract these two numbers, or I would add up to figure out that the length of segment MN just from here to here is 6 units in length. The segment addition postulate also works when you're looking at examples that have variables in them that you need to solve. Now, for some reason, the plus sign right here copies a little bit lightly, so go ahead and make sure on your papers that it's really clear that that says 2x plus 3. I don't know how long this one is. I don't know how long this one is, but I know that the whole thing is 27. Notice that these two little pieces kind of look like they're equal to each other, x to y and then y to z. It kind of looks like y is right in the middle, but we're not going to assume that it's in the middle because the picture's missing those markings that would let us know that that was the case. So I don't know if they're equal, but I know that whatever this one is plus whatever this one is equals the whole thing. And so that's the equation that I'm going to write down, and then I'm going to solve. So 2x plus 3 plus 3x minus 1 is equal to 27. I use what I'm given in the picture to create an equation that I can then go through and solve. This piece plus this piece equals the whole thing. This equation has two variables, or one variable, but in two places. They're both over here on the left. So I'm going to combine those like terms and then combine these like terms. So that'll give me 5x plus 2 is equal to 27. And then I'm going to go through and do solving steps to finish and get the x all by itself. So when I go through and I finish solving for x right here, I'm going to get x is equal to 5, which is part of my answer to the question. But this one also wants me to figure out how long it is from x to y. So you always have to go back to your picture and see which part you're plugging it into. They don't want me to figure out how long it is from y to z. They just want me to figure out how far it is from x to y. So I'll go ahead and circle that on my paper. From x to y is 2x plus 3, and so what I'm going to do is I'm going to say to find out how long it is from x to y, I'll plug in the 5 that I just got for x in for x right there. Let's see, 2 times 5 is 10, and then 10 plus 3 is equal to 13. So this piece from here to here would be 13. On a test or something like that, if you wanted to, you could also plug the 5 in over here, because if this part's 13, then this part over here is going to have to be 14 to give you 27. And if you plug the 5 in right here to this one, you'll also get 14. So it's a great way to check your answer. On 3B, this one's a little bit different because on this one, it doesn't tell you how long the whole thing is, but the picture has these markings right here that tell you that these two pieces are equal. M is the midpoint of this segment. So I'm not going to say x plus 9 plus 4x equals something else. I'm going to set these two expressions equal to each other. So I'm going to say x plus 9 has to equal 4x. And so when you go through and follow your solving steps to get the x all by itself, for this one you're going to get x is equal to 3. And you'll also get 3 if you moved the 4x over here and solved it that way as well. But x equals 3 is the answer for this one. They want us on this one to figure out how long it is. Let's see. We're finding from L to N. So L to N is the whole thing. In order to find out how long the whole thing is, there's a couple different ways you can do that. You could plug the 3 in right here to this part and then just double that because you know that they're equal to each other. But you could also plug that into both sides here and here to make sure that you get the same thing out for both of them. It's really just up to you to decide. So for L to M, I would plug in the 3. So I would get 3 plus 9. So from L to M, it would be 12, but that's not what they want me to find. They want me to find the whole thing. From M to N, I would do 4 times 3, and that would also give me 12. That's good that they both come out to be the same thing, by the way, because you need them to be equal in order for M to be the midpoint, which the picture said it was. And so to figure out from L to N, I would take those two and I would add them up. So from L to N, it would be 12 plus 12. So I would get 24 units from L to N. And that would be my answer for the question right there. This final example on the page, let's see. You don't have a lot of room to work vertically, so I'm going to set up and solve my equation over here. Notice in this one for number 4, it says M is the midpoint of the segment below, but it doesn't give you the markings on the picture. Because it says in the directions that M is the midpoint, that means that you know that M is in the middle. So you could put the markings on the picture, or you could just proceed and set the two equal to each other. So 4x minus 12 is equal to negative 2x plus 21. And then you're going to go through and you'll solve that one for x. And so when I add the 12 to both sides, I'm going to get 6x is equal to 33. And then I divide both sides on this one by 6. Let's see, 33 divided by 6 gives you a decimal answer. You get 5.5. So you could write it as a fraction, or if you wanted to, you could also write it out as a decimal. Either way, it's fine. But you're going to get x equals 5.5. I'll squeeze it in down here. And so that's the answer that you get for x when you solve that one. Now they want us to figure out how long it is from P to M, so that's just this piece over here. So once I know that x is 5.5, I'm going to plug it in. So from P to M, it's going to be 4 times 5.5 minus 12. And so let's see, 5.5 times 4 is going to give me 22 minus 12. And so I'll get that from P to M is 10 units in length for this one. So again, the biggest thing that I want you to take away from the segment addition postulate is that you're just doing part plus part equals whole.